These are your notes for the elimination method for solving systems of equations. We've already done the previous two methods, which were substitution and graphing. And so this is the third and final method. Here's three examples. So the steps are listed up on the top right. You will not always use all these steps. The first step is to multiply one or both equations by something to get the variable to cancel. Sometimes you don't have to do that. Second step, add the equations together. You will always do that. Solve for whatever is left, and then substitute that back in to find the other one. You might notice that the fourth step is the same as when we do substitution. Okay, so I'm looking at these two equations, and I want to look to see if I can add them together and make one of the variables go away, make it cancel. So I see right here I have a positive and a negative y. So I can add these together. 2 plus 3 is 5, negative y and positive y is 0. 5 plus 5 is 10. So I got rid of y, I eliminated y. Now I can solve for x. So x equals 2. Always write it down as half your solution. And then we substitute back in here into one of these two equations. We put in 2 for x. So I'm going to put 2 in for x right there. So I get 4 plus y equals 5. Nice easy equation. Y equals 1. And then what I'm going to do is, to make sure it works, I'm going to go to the second equation and plug in my answers for x and y. So I get 6 minus 1 equals 5. It works. Second equation, I'm going to look. If I add these together, I'll get 4x minus 1y equals negative 8. And that does not help me eliminate anything. So I'm going to have to multiply one of my equations, maybe both, to get rid of something. So I'm going to look right here. If I want to get rid of x, if that's the 3, I can change that to a negative 3 by multiplying the whole equation times negative 3. So there's no getting around this. You just need to rewrite the first equation and then multiply every term in the second equation by negative 3, not just the one you're trying to change. So negative 3x plus 9y and negative 27. Don't forget to do that to both sides. So 3 and negative 3 is 0. I get 11y equals negative 44. Divide by 11. Y equals negative 4. Since I know y is negative 4, I can go back to the first equation and put in negative 4 for y. So I can solve for x now. So 3x equals negative 9. Divide by 3x equals negative 3. You want to check your answer, take it to the other equation. Negative 3 minus 3 times negative 4, and see if that equals 9. Negative 3 times negative 4 is 12. So you got it checked, it's right. Third example, again, I can't just add them. So I multiplied one equation. This is going to be when we multiply both equations. So I'm going to pick which variable to eliminate. I'm just going to eliminate the x's. So I know 3 and 2 both go into 6, but I need one of them to be positive and one to be negative. It doesn't matter. So I'm just going to multiply the top equation by 2. 6x plus 4y equals negative 12. And I'm going to multiply the bottom one by negative 3, not just 3, because I want this to be a negative 6x. So negative 6x, don't forget to multiply everything else by negative 3. Minus 15y equals negative 21. Now I can add. Now I've changed it to a problem where I can just add them together. So that's negative 11y equals negative 33 divide by negative 11, y equals 3. Take my solution back to one of the two equations. I'll go to the top one. 3x plus 2 times y equals negative 6 because I have a y. Now I'm going to solve for x. So 3x equals negative 12 divided by 3, x equals negative 4. Let's check it in the second equation. Second equation is 2x plus 5y equals 7. So 2 times negative 4 plus 5 times 3, we're going to see if that equals 7. And it does. So we have it. So those are your three examples. We'll do more in class.